Hello everyone. Today I'm going to give a demo of Parkinson's detection using machine learning. So in this project, we have collected the data set of Parkinson's detection and training is done through the decision tree random forest XGBoost and k-nearest neighbor. So in this, once we collected the data set, we will train the data set into these four algorithms. Testing is done through the GI part, which will get the highest accuracy. That one we will take for the prediction part. So we can check for the data set. So this is the data set. So this is the data set we have collected. So these are the features. So these features will be take for the X as the input, Y as the status as the target, and these are features as the inputs. So this is the training code. So initially, these are the libraries we use for to train the models. Here we are reading the data CSV file. These are the features. Y are the status. And once we splitted X and Y, split the data set into training and testing. And here we are defining the model decision tree. After that, we will get the accuracy. Once the training is completed, decision tree file will be saved as a local file in the particular folder. Next, second algorithm random forest we have used. Define the model, fit the model, and the predict. After that, you will get the accuracy. And same as XGBoost. XGBoost will get the accuracy. After that, we will save the pickle file. And next, k nearest neighbor will save as a pickle file. And after four algorithms train, get the comparison graph decision tree. Here we have used dictionary data type. Uh, these are the keys and these are the values. And using matplotlib, it will display the graph. You click on run more. So these are the accuracies you will get. And this is the graph of training. Once we run the training file, it will get decision tree as the highest accuracy. And random forest exhibit KNN. So here we will use for testing purpose, for prediction purpose decision tree. Click on file, open, testing. So this here we have used decision tree pickle file, and this is for GI part. And here we use these are the features to predict Parkinson's detection, control model. So this is the output. Here you can enter the values. For predict. So we'll get the Parkinson's negative. Similarly, we can check for another input. Click on predict. So here get Parkinson's positive.